For nearly 5 decades, the UH-60 Black Hawk has been the backbone of American assault aviation. Now the U.S. Army has committed roughly $70 billion to replace it, with an aircraft that does not fly like any helicopter before it. The MV-75 cruises at 280 knots, nearly double the Black Hawk's speed, and covers distances that once demanded mid-mission refueling in a single lift. This is not a routine upgrade. It is the largest rotorcraft investment in Army history, and the reason behind it reveals just how dangerously modern warfare has outgrown the machine that once defined it. Designed in 1979, the UH-60 Black Hawk rolled out for a world defined by the threat of Soviet armor and the dense forests of Central Europe. Its mission was to move troops, evacuate wounded, and deliver supplies under fire, fast enough for the time, tough enough for the battlefield it was built to face. Over the decades, it became a symbol of American military reach, logging millions of flight hours across every major conflict since Grenada. But the world it was made for no longer exists. Nearly 50 years after its debut, the Black Hawk is showing the wear of constant deployment. Its airframe, avionics, and engines were engineered for an era before GPS jamming, long-range missiles, and the need to leap hundreds of miles between scattered bases. The average Army Black Hawk now requires ever more maintenance hours to stay mission-ready. Spare parts are harder to source, and mechanics fight not just fatigue, but the limits of a design never intended to last this long. Fleet-wide, the numbers tell a story of aging steel. The Army has fielded more than 2,000 Black Hawks, with some aircraft in service for over 40 years. Inspections have revealed transmission and rotor issues that ground entire units, while recent crashes, 5 fatal accidents that killed 12 soldiers in just 18 months, underscore the risks of pushing legacy airframes past their intended lifespan. The Black Hawk's top speed of around 150 knots and a combat range of roughly 268 nautical miles, once in the standard. Today, these numbers define the ceiling, not the baseline. As the Army looks toward the Pacific and other vast theaters, the limits of a helicopter born in the Cold War have become impossible to ignore. $70 billion. That's the projected cost to develop, build, and sustain the Army's next-generation vertical lift fleet over its lifetime. The figure isn't just a sticker price for a new helicopter. It represents decades of investment spanning research labs, production lines, spare parts, maintenance crews, and software updates that will keep the MV-75 flying into the 2060s. This sum covers the entire life cycle: engineering and testing, initial manufacturing runs, full-rate production, and the long tail of support contracts needed to keep hundreds of aircraft mission-ready around the world. Every dollar in this estimate is tied to a specific demand. The Army is not just buying airframes, it is buying the ability to move soldiers and supplies across vast distances, to operate beyond the reach of enemy missiles, and to adapt as threats evolve. The $70 billion projection includes not only the cost of the aircraft themselves, but also the digital infrastructure for mission planning, the training simulators for new pilots, and the logistics networks that will keep these tilt rotors in the air. This financial commitment forces hard choices and fierce competition. The Army must justify each line item to Congress, proving that every aspect of the MV-75's design and support plan delivers value, whether that is measured in flight hours, readiness rates, or the ability to survive in contested airspace. The scale of the investment will ripple far beyond the Pentagon. It shapes where factories are built, how suppliers are chosen, and which communities will see new jobs and long-term economic growth. For the Army, this is not just about replacing an aging fleet. It is about laying the industrial and operational foundation for a new era in military aviation. The Army's vision for future flight is organized under a sweeping initiative called Future Vertical Lift, FVL. This is not a single helicopter program. It is a long-term overhaul of the entire rotorcraft fleet. Under the FVL umbrella, two competitions stand at the forefront: the Future Long-Range Assault Aircraft, FLRAA, and the Future Attack Reconnaissance Aircraft, FARA. Each serves a distinct role. FLRAA is built to handle long-range assault missions, carrying troops and equipment over distances that would push the Black Hawk well past its limits. FARA is designed for attack and reconnaissance, filling the gap left by the retired Kiowa Warrior and aiming to operate where speed, agility, and sensor reach matter most. The FLRAA contest drew two industry teams with radically different approaches. Bell entered the V-280 Valor, a tilt-rotor design that blends helicopter lift with airplane speed. Its main rival was the SB-1 Defiant, a coaxial compound helicopter built by the Sikorsky Boeing team. Both platforms promise speed and range far beyond the Black Hawk, but their engineering philosophies could not have been more different. While FLRAA targeted the Army's assault fleet, the FARA competition ran in parallel, with Bell's 360 Invictus and Sikorsky's Raider X vying for the attack and scout role. This dual track structure is deliberate. It lets the Army push technology in two directions at once, maximizing the chance of a leap in capability while hedging against the risk that any one concept might fall short. Understanding this framework is essential because the next chapters will follow the FLRAA path, where Bell and Sikorsky Boeing faced off in a contest that would set the course for Army aviation for decades to come. Bell's tilt-rotor design for the MV-75 breaks sharply from everything that came before it, not just in appearance, but in the logic of its mechanics. Instead of mounting the engines at the tips of the wings, as seen on the V-22 Osprey, the MV-75's engines are fixed in place within short, stubby wings. Only the rotors themselves tilt, pivoting up for vertical takeoff and landing, then forward for airplane-like cruise. This shift means that the heavy, heat-generating engines never move, eliminating the complex swiveling connections and vulnerable wiring that have long challenged maintainers in the field. The fixed engine approach brings a cascade of practical benefits. With fewer moving parts in the tilt mechanism, there is less wear and tear and fewer points of failure. Maintenance crews can access and service the engines more easily, reducing downtime and simplifying logistics. This is an essential advantage when every hour on the ground is an hour lost from the fight. The streamlined drive system, running through the wing, delivers power to the rotors without the need for massive tilting gearboxes. This architecture not only cuts weight, but also removes the need for intricate cooling systems and extra bracing, both of which add complexity and cost. Engineers at Bell designed the MV-75's stub wings to house the engines securely, protecting them from battle damage and environmental stress. By letting only the rotors articulate, the whole system becomes more robust and easier to inspect. The result is a machine that promises higher reliability and faster turnaround between missions. These qualities translate directly into operational tempo on the battlefield. This mechanical simplicity is the foundation for the MV-75's leap in performance. It also paves the way for advanced digital controls, including fly-by-wire systems that will allow pilots to handle transitions between hover and forward flight with unprecedented smoothness. As the story moves from engineering to numbers, This architecture stands as proof that the MV-75's claims are built on more than marketing. They rest on hard-won lessons from decades of military aviation. Numbers draw a line in the sand. The MV-75, now the Army's official designation for Bell's tilt rotor, is engineered to cruise at 280 knots, nearly double the Black Hawk's top speed of 150 knots. In practical terms, that means a flight from Fort Campbell to the edge of the Gulf can be done in under 2 hours, while the Black Hawk would take nearly 4 hours. Push the MV-75 to its limits, and it breaks the 300-knot barrier. A threshold that no conventional helicopter can approach. Range is where the gap becomes a chasm. The Black Hawk's combat radius, roughly 268 nautical miles, once defined the outer edge of Army air assault. The MV-75 is projected to cover more than 1,700 nautical miles without refueling, over 6 times farther. This is not just a marginal gain, it is the difference between being tethered to a patchwork of forward bases and being able to leap entire countries in a single mission. For commanders, that translates to options, rapid reinforcement across the Pacific, surprise insertions deep behind enemy lines, and the ability to bypass threats that would have forced older helicopters to land or turn back. Endurance, too, gets a new definition. The MV-75 can sustain high-speed flight for hours, maintaining operational tempo over vast distances where the Black Hawk would run out of fuel or mechanical margin. This leap is not theoretical. Army evaluators clocked the V-280 demonstrator at 280 knots in test flights, with top speeds above 300 knots and performance that held up over more than 200 flight hours. The hard data leaves little room for nostalgia. The MV-75's speed and range are not evolutionary. They are a break from everything the Army has fielded before. When the doctrine calls for reach, mass, and unpredictability, only a machine that can cross continents at jet-like speeds will do. A next-generation assault aircraft is only as valuable as what it brings to the fight and how it survives getting there. The MV-75's cabin is designed around the needs of a modern infantry squad, with space for 12 to 14 fully equipped soldiers, matching the Black Hawk's capacity, but delivering them at ranges and speeds the old platform cannot touch. The interior is shaped for rapid loading and unloading, with a wide ramp and side doors that let troops deploy in seconds, even under fire. Cargo is not limited to what fits inside. Dual external hooks under the MV-75 can lift a combined 10,000 pounds, enough for a Humvee, a howitzer, or critical supplies. This outsized lift means commanders can move not just people, but heavy gear, bridging gaps that would otherwise require multiple sorties or vulnerable ground convoys. The ability to sling load at high speed and over long distances expands what an air assault can achieve, turning the MV-75 into a force multiplier for everything from humanitarian relief to frontline combat. Survivability begins with the airframe. The MV-75 uses advanced composite materials that absorb damage better than metal, reducing weight while increasing resilience against small arms fire and battlefield debris. Redundant flight control systems and split electrical wiring ensure the aircraft can keep flying even after sustaining hits. The digital backbone, fly-by-wire controls, and modular avionics lets crews adapt to electronic warfare threats and plug in new countermeasures as technology evolves. Passive stealth shaping and signature management lower the odds of detection by radar and infrared sensors, giving the MV-75 a fighting chance in contested airspace. Longer range is not just a number on a chart. It means fewer forward arming and refueling points, less exposure for ground crews, fewer vulnerable supply lines, and more options for unpredictable tactics. The MV-75's payload and survivability are not just upgrades, they are the tools that let future squads operate deep behind enemy lines, confident that their ride in and out is built for the battlefield of tomorrow. Sikorsky and Boeing joined forces on a machine that challenged every assumption about what a helicopter could do. Their SB-1 Defiant wasn't a tilt rotor, but a coaxial compound helicopter, an approach that stacked two rigid rotors on the same axis, spinning in opposite directions to cancel out torque. This configuration, paired with a rear-mounted pusher propeller, delivered a level of speed and agility that conventional helicopters could never match. In testing, the SB-1 Defiant reached over 247 knots, pushing the boundaries of rotorcraft aerodynamics. The counter-rotating rotors provided stability and lift without the drag of a tail rotor, while the pusher prop added raw forward thrust. Sikorsky-Boeing engineers argued that this setup could offer rapid acceleration, tight maneuvering, and lower vibration, all with a simpler transition between hover and high-speed flight. The SB-1's design wasn't just a technical experiment. It was a direct answer to the Army's call for a leap in battlefield mobility. Every detail, from the composite blades to the digital flight controls, was aimed at delivering a platform that could keep pace with the evolving threats of the 21st century. The competition was real, and the decision was anything but predetermined. On December 5, 2022, the U.S. Army made its decision public. Bell's tilt rotor was selected as the winner of the Future Long-Range Assault Aircraft competition. The announcement brought years of technical trials, side-by-side demonstrations, and industrial lobbying to an abrupt close. But the contest did not end there. Sikorsky, backed by Boeing, filed a formal protest, arguing that the selection process had failed to properly weigh the merits of their coaxial SB-1 Defiant. For 4 months, the entire program sat in limbo, while the Government Accountability Office reviewed every detail of the Army's procurement process. In April 2023, the GAO issued its ruling, denying the protest and upholding the Army's choice. With that verdict, the last legal barrier fell. The Army's commitment to Bell's tilt rotor became binding, locking in the MV-75 as the next centerpiece of its assault fleet. The decision cleared the way for manufacturing investments, supplier contracts, and the rapid buildup of an industrial base designed to deliver a generational leap in battlefield mobility. The program shifted overnight from competition to execution. Bell's victory set off a surge of investment across North Texas. The company committed $632 million to expand and modernize its Fort Worth facilities, transforming what had been a legacy helicopter plant into a hub for next-generation composite manufacturing. New fabrication lines now stretch across the factory floor, dedicated to building the MV-75's advanced airframes and drive systems. The supply chain is being rebuilt from the ground up, with dozens of regional firms tapped to produce everything from carbon fiber panels to digital avionics modules. This industrial push is more than a headline about jobs. Local governments and workforce programs are partnering with Bell to train hundreds of new technicians and engineers, preparing them for the demands of high-rate production. The economic impact ripples outward. Every contract signed and every machine tooled represents a bet on the future of American military aviation. With money flowing and equipment arriving, the abstract promise of a new assault aircraft is turning into a physical reality, one shift at a time. Milestone B approval launches the next phase. 6 MV-75 prototypes are now cleared for construction, with the first flight scheduled for 2026. The program's timeline is set. Low-rate initial production begins in 2028, and deliveries are locked for 2029. The 101st Airborne Division stands at the front of the line, slated to receive the Army's first operational aircraft. For soldiers at Fort Campbell, this means training on a machine that promises to redefine their reach and speed. The calendar is no longer theoretical. Every milestone brings the MV-75 closer to the field, and the Army's future closer to reality. Army planners now look beyond the horizon of traditional helicopter warfare. In the Indo-Pacific, where islands and coastlines stretch for hundreds of miles, the MV-75's extended range turns geography from a barrier into an advantage. Assault legs that once demanded chains of forward bases can now be covered in a single flight, more than 500 nautical miles without refueling. This unlocks a new model of distributed operations. Units can leap between dispersed positions, complicating enemy targeting and reducing the need for vulnerable supply hubs. For regional allies, this reach means joint missions no longer hinge on the slowest or shortest range aircraft. Interoperability improves, and the Army's presence becomes less predictable, more agile. As doctrine adapts to these realities, the MV-75 is not just a tactical upgrade, it is a tool for deterrence and reassurance across an entire theater, reshaping how power is projected in the world's most contested region. This isn't just a new helicopter. With the MV-75, the Army accelerates troops nearly twice as fast and far as the Blackhawk, reshaping doctrine across continents. Billions invested, manufacturing ramped in Texas, and an industrial base recalibrated. This is a generational pivot, not a routine upgrade. The battlefield calculus shifts now. The next conflict will not wait for yesterday's machines. What do you think? Does this redefine military power or just move the goalposts?